Alright, so here's our very brief intro to conic sections. Alright, so this is the last topics in analytic geometry we're doing. Elliptical orbits, or orbits of planets, asteroids, comets, anything that's orbiting another body. So any celestial body is in some sort of orbit. Our galaxy is in orbit around its the center of our galactic cluster. All these follow paths that would be classified as conic sections. The planets are primarily ellipses, right, with two foci. We'll get into that. Nothing really orbits in a circle, though that's possible. And then comets sometimes will come very close and then kind of slingshot around, and they don't bend like that. They slingshot around and never connect, and they're never in a closed orbit. Those are called hyperbolas. These are all conic sections. So why do they call them conics? Basically, if you take two cones that are proportionally the same, put one on top of the other, and then slice them with a plane. You can see if you slice them with a plane this way, you get a perfect circle. If you tilt it a little bit, you get a tilted circle or an ellipse. And then if you slice it up here, parallel with this line, up through here, you're going to get a parabola. And then if you cross another certain boundary, you can slice it and see how this will never hit that cone. So, or even if you sliced it this way, it would never hit that cone. It would still give you a parabola. Here, if you are steeper than this angle, then it hits and you get two hyperbolas because it cuts it that way. Alright, so these are the basic shapes of cutting a cone. That's why we call it conic section. Cut it flat, you get a circle. Cut it at an angle, you get an ellipse. That would be like an elliptical orbit, like our planets around the sun. And then a parabola is that familiar quadratic equation that we have studied. And then a hyperbola. This is not a closed loop. It's actually this, and it always has a mirror image that is down here too. So there's several ways. This is the geometric understanding of it. We're not going to do a lot or require you to build these or be able to graph these in space or anything. But this is where we get the term conic section. We're also going to talk about them algebraically. So these are some degenerate conics. Basically, if you slice it right here, you get a point. Slice it right along the edge, you get a line. If you were to cut them in half, you just get the intersection of two lines. So those are less interesting conic sections. This is what we're going to call standard form. All right, get it all to one side, set it equal to 0. We go x squared, xy, y squared, x, y, and just a number. All right, so we may not have numbers for all of these. So an example might be like a 2x squared plus y squared minus x equals 0. So we don't have this term, we don't have this term, and we don't have this term. Still, technically, that would be the standard form. For the circle, what we're going to be starting with is this. So watch the next video and be able to do your homework.